It is now time to test our knowledge and understanding of Newton's laws of motion. To get the best out of these questions, I will advise that you go through lesson 1 to lesson 7. Let's go through our multiple choice questions. Question 1.1. I must mention that, remember, when we solve questions at the back of our minds, we are applying the academic constitution. This was discussed on a separate video called Academic Constitution. Please visit that video to learn this technique. This is just a set of rules that we'll use to solve problems. So in the background, when I do these problems, you will come to realize that I'll interpret the question, classify the question, answer the question, and navigate the question. So I'll start with 1.1. So in 1.1, they say, which physical quantity is the same as the product of mass and acceleration? Now let's fix the English here. The word product in mathematics means a number that you get after multiplication. So if I say the product of 2 and 3 is 6, this number here is a product, is a number that you get after multiplying 2 and 3. So in this question, they tell us that the product of mass, meaning we multiply mass and acceleration, what do we get? We get the net force. So it means our answer here cannot be inertia, cannot be Newton's second law. It cannot just also be a force. Because remember, there's a difference between a force and a net force. If you look at lesson 1, we actually talk about those two. So our answer here would be C. 1.2. They say, which one of the following statements is correct for the law below? So they tell us here that they've given us a law. They tell us that they've given us a law, and which of the statements that they've given us here, the options A, B, C, and D, is correct. So our law here that they've given us says that the net force acting on an object is equal to the mass of the object multiplied by its acceleration. This statement says the net force is the same as the mass multiplied by the acceleration. I mean, this quickly, when you look at it, it does ring a bell, right? It is Newton's second law, so our answer has to be C. We spoke about this when we did our lesson in Newton's second law. We introduced this equation. 1.3, they say the derived SI unit for the physical quantity force is. The derived SI unit for the physical quantity force is. So here we're looking for the SI unit of the force. Now, when we say derived, we mean that this SI unit comes from other quantities, right? We generate it, we come about it from other quantities, right? So I just want to go back to this formula quickly. If you look at this formula here, if I put the SI unit for mass is kg, if I put for acceleration is meters per second squared. And we said that the SI unit for a force is a Newton, and that 1 Newton is the same as kilogram meters per second squared. So the SI unit of a force, right, even if here I've just done it with a net force. Remember that a force and a net force, they are different, but they have the same SI unit, right? So our answer here has to be D. Because we have kilogram meters per second squared. Now we'll jump into question 1.4. They say consider the statement below. The force that opposes, that's your first clue, opposes the attempted, that's the second clue, of motion, right? The force that opposes the attempted motion of a stationary object in a direction parallel to the surface. I mean, they've given us all the information we need. If a force opposes and it attempts, is to try to move something. A stationary object, stationary means it's not moving. And this force again is parallel to the surface. It must be frictional force. But because it is attempting to move a stationary object, an object that does not move, and it's also parallel to the surface, it is the static frictional force. In fact, I said on our lessons, if you go to where we study the categories of forces, I think that was our lesson 2, you'll realize that I said to you the word static comes from the word stationary. That's how you remember static frictional force. So our answer here has to be A. Then we're going to jump to 1.5. They say consider the statement below. They say an object has zero acceleration, right? So this object has zero acceleration. It does not move. Now, they say which one of the following is correct about the forces acting on the object, about the forces acting on the object. Now, if you look at the options here, they say more than one force acts on the object. If we have an object sitting like this, and there is this force F here, right? And maybe this frictional force here. The first option doesn't have enough information for us to conclude, because if you say more than one force, I can have these two forces here acting on this object. We need more information. This force could be greater than this one so that the object will move in that direction, right? These two forces can be also equal so that the object moves at a constant velocity, because when they are equal, the acceleration will be 0 and the net force will also be 0. But we are not told in option A if that's the case. We are not told if these forces are equal. They just say more than one. And more than one is tricky because actually we could have another force here, F2, right? We don't know, maybe we could have another force there, so we don't know. So this option here is out. Then they say no forces act on an object, right? This sounds more like something that makes sense. If there are no forces acting on this object, it means that if there are no forces acting on this object, there are no forces acting on this object, it means that the applied force is going to be 0, right? And the acceleration, or the net force, is going to be 0, and the acceleration is going to be 0 because there's no any forces acting on the object. It won't move. I'll keep that on hold because it might be wrong. We have to check other options in this case. Now, only one force acts on the object. There's no way that one force can act on this object and then it does not move. Because if it does not move, it means there's friction that's stopping the object from moving. So if there's only one force, then the object has to move to that direction. So that's not an option as well. Then they say two unequal forces act on object. I mean, when I spoke about A, I spoke to this to say if the forces are unequal, the object will either move in the direction where we have a greater force, right? So B seems to be the best option in this situation. So our answer would be B, right? 1.6, they say the net force causes a truck to move with a constant acceleration. On a horizontal road. The acceleration is now doubled. Which one of the following is correct? Right? So here I see my options. They say all forces acting on the object double, both the net force and the mass of the truck double. The mass of the truck doubles, both the net force and the mass are halved. Okay. I think the best way to do this would be to look at our truck to say we have a truck here. Right, we have a truck here. This truck experiences a force from the engine that push it to the right, and obviously it will experience a frictional force, kinetic frictional force, right? Now, when we want to find the net force acting on this truck, we'll say net force is equals to the mass times the acceleration. But now when I choose my direction here, you will realize that my net force is also given by the sum of forces acting on the object. It's going to be this force here, F, minus this force here, kinetic friction, because it goes in the negative direction, giving me this scenario. Now, if this truck here, the acceleration is down. Remember here on the first scenario, we have the acceleration A, right? Now we double the acceleration. It becomes 2A, right? This means that the net force will be equals to mass, but in this case we'll have 2A because we've doubled the acceleration, mass times acceleration, but the acceleration is now doubled, it's twice A, right? If I double the acceleration, we know from Newton's second law that I also have to double the force because they are directly proportional, those two quantities. Now this means here I'm going to have 2 F minus Fk is equals to 2ma. So this would mean I'll have 2F minus Fk is equals to 2ma. Now look what's happening here. It has to be clear to you that all the forces acting on the object, which is this force and this force, are now doubled as well. They are now doubled as well from this formula. You see, I didn't multiply this one by 2 as well, because remember, we multiplied the 2 here, we multiplied the 2 there as well. So here we're going to have 2Fk. So both these two forces, or all the forces that are active on this object, are doubled. So my option has to be that all forces acting on the object are doubled. It has to be A, right? It has to be A. Let me erase here so that I can write our answer. So 1.6 1.6, our answer is A. Now we move on to 1.7. We say here a particle of mass m experiences a force F which causes the particle to move with acceleration A. So to represent this as a particle, I'll just say this is the particle. It has mass m, right? It experiences a force which is F, and this force causes this particle to accelerate with a. Then they then come and say another particle that has twice the mass of the first particle experiences the same acceleration as the first particle, right? So here, then they say which one of the following is correct, is the correct force. Okay. Here we know that the net force is given by mass times acceleration. And because the only force acting here is F, I'll only put F here when I add my forces. There are no any other forces maybe that are going in that direction or anything of that sort. So the only force acting here is F that we know. So this force F is the net force. Actually, it's the same as the net force. Now is equals to the mass of the particle, which is m, and the acceleration of the particle, which is m. Now here we have another, remember this is the first particle, here we have the second particle. They say the mass is twice m. We only changed the mass right in this particle, but it moves with the same acceleration, so it has the same acceleration as the first part here. The acceleration is the same. So what we're looking for is this force here, right? What is this force here? How will it look like? You know, at the first glance, I can tell you that the force should also double. And the reason why the force should double is that the net force and the mass are directly proportional, right? But you know, you can prove this by a calculation where we come and say the net force is equals to mass times the acceleration. And we're saying here that, so here I'll call this F prime, right? So that I'll call that F prime because it's the net force prime. I'll call it the net force prime. The reason being is because this net force here is not the same as this net force here because the mass has changed, you know. So in this case, when we come and substitute, remember this is our Newton's second law. Now we are substituting in that equation of Newton's second law. We're saying the mass now is twice m, right? The mass now is twice m, so that we have 2m times a. The acceleration hasn't changed, it's still the same acceleration. Now if you look at this properly, you would see that I can put brackets here, so that now I have two, I have two, but now this part here is exactly this part here, right? So we can replace this part by the F. So this means the new force, the new net force prime is equal to 2F. And our option there has to be B, which is 2F, right? So I'm going to erase here because we now got our answer. So you know, the use of Newton's second law is very important in helping us to compare situations. Now we have 1.8, right? They say a box is being pulled to the left by a force F, right? We're pulling the box by a force F, and if you look at this force, right, it's between the x and the y axis, so it has the x and the y component as a result, as shown in the diagram, right? In fact, they've even drawn those components for us. They say which one of the following statements regarding the magnitude of the normal force acting on the box is correct, right? So we want to calculate the magnitude of the normal force here. Already from our previous lesson, lesson 7, we know that in this type of a situation, the normal force is not equal to the force of gravity. Actually, it's a combination, right? Which we'll check here. What combinations do we have? If you look at this problem here, you will see that we have the normal force going in that direction. We also have the force of gravity going in that direction is given by mg, right? Now, because we're looking for the normal force, I can use this type of direction to say anything that goes up is positive and anything that goes down is negative. Now, I'll come on this side to then find the net force in the y is equals to 0, right? And it's equals to 0 because the object does not move in the vertical, it has a 0 acceleration in the vertical direction. Now here we'll say the normal force, which is positive, minus mg, which is negative, but we're going to add here the component of gravity. No, the component of this force F, sorry, not gravity, the component of this force F, because it also goes up. You see here I have two forces that go up, right? So we're going to also add that force to say this is Fy and is equals to 0. And from here you can see that the normal force would be mg. It will be positive as it goes that side, then this will be negative as it comes this side. Now let's interpret this answer. If you look at this answer here, we are having the force of gravity and we are subtracting from it the component in the y direction, right? We are subtracting the vertical component, meaning we are reducing, we're making it to be smaller, we're making the normal force to be smaller, right? We're making the normal force to be smaller because we are subtracting a number from it. We are subtracting the component of gravity from it, right? So on our options, they say the magnitude of the normal force is equal to the force of gravity. No, they are not equal, right? They are not equal. You can see from this equation that these two are not equal. There's actually another factor that we are subtracting. They say larger than the force of gravity, definitely not larger. We are not adding there. We are subtracting, we are reducing it, right? Equal to the vertical component of the force F, no, right? The normal force is not equals to this component, so this is wrong, right? This is smaller than the force of gravity. I mean, we just said here it is actually smaller than the force of gravity, right? So 1.8, let me go back to my black pen. 1.8 should definitely be D. Should definitely be D. Now I'm going to erase here so that we can use this space to do further calculations. Now we're going to 1.9. They say a block of mass M is placed on a plane with inclination beta with the horizontal, right? So we have a block that is placed on an inclined plane that makes an angle beta. The block remains stationary on the inclined. Very interesting, right? Remember that when you draw your forces here, you will have the force of gravity going in that direction, that is mg, right? That is Fg is equals to mg, right? The mass times the acceleration. Now, because this force is between the x component and the y component, remember that this horizontal part here is our x-axis, right? This is our x-axis. I'll choose it as positive x, and this part here is actually our y-axis, right? I'll choose this side here as positive y, right? Now the component of gravity is in between, right? Is located here in between these two axes, therefore it must have components, and we said that the x component, sometimes called the parallel component of gravity, is given by mg, the sine of beta. It will always be like that. And we also said that the y component will be given by mg, the cos of theta. It will always be like that as well, right? Because also we mentioned at some point when we explained this in the previous lesson 11.7, that the angle here will also be beta. The angle of the incline is the same as the angle there between the forces, right? It's also the same as the angle between the forces. Now, for this object to remain stationary on top of the incline, it means there must be the force of friction, right, that prevents this block from going down. So it means here we have a static frictional force, right? So that's what's happening there. Now they say to us here, so that's how you'll interpret the problem here. They say to us here the magnitude of the coefficient of static friction is, right? They give us options. Now for me to get the static frictional force, I'll start first by finding the forces that are acting in the y direction. I'll say the force in the y direction is equal to 0 because the forces are not moving in the vertical direction. Now, maybe also what I can add here quickly is the normal force. There is the normal force. The surface pushes the object vertically upward like that. So now the normal force will be positive according to our chosen direction minus mg the cos of theta. So what am I doing here? I'm saying this minus that because they are in the y direction, right? Is equals to 0. So this means my normal force is equals to mg cos of theta, right? Then I'll come and say my forces in the x direction are equals to the mass times acceleration, right? And my forces in the x would be mg sine beta minus the frictional force, which is the coefficient of static friction force times normal force, and then here I would say is equals to 0. Why? Because they've said to us that this object is stationary, meaning the acceleration here is equals to 0 meters per second squared. And if you multiply by 0 here, you get a 0, right? Now, I will substitute this force here on the normal force, right? So that I have mg, the sine of beta, is equals to, okay, before I do the equal sign, perhaps I could just say the coefficient of static friction times mg cos theta, right, is equals to 0. Now I'll take this whole thing here to the other side so that I have now the coefficient of static friction mg cos of theta mg sine of, no, this is beta, it's not theta. This is beta, it's not theta. Cos of beta. Now, if we divide both sides by mg cos of theta, the reason why I divide by mg cos of theta is because I want this to cancel here so that I am left with coefficient of static friction, right? I'm left with this guy, then is equals to, now when we look at this side here, look what happens here. The mg and mg cancels, then I'm left with these two guys, sine beta over cos beta, which is the tan of beta. Now this should be my option on the options provided, and if you look at that, you would see that C actually fits really well on that. So 1.9 1.9 C as our option, right? We have C as our option. Let me just erase that quickly so that our answers are clear. I hope, guys, this makes sense to you and you are following. We also have the last question here, 1.10. They say a car moves up an inclined surface at a constant velocity, right? Now, what do we know about constant velocity? We know that when we have a constant velocity, we talked about this when we did Newton's second law, that the acceleration is going to be 0 meters per second squared. We know that the net force is going to be 0 newtons as well, right? When there is no, when an object moves at a constant velocity, we know from Newton's second law that there is no net force, right? And later on, when we defined equilibrium, we did say that when there is no net force, it means the acceleration is also 0. And also with Newton's second law, actually, when the net force is 0, the acceleration is also 0. Now, they say here now, which one of the following statements about the acceleration of the car is correct? The acceleration cannot increase, the acceleration cannot be constant, right? The acceleration cannot decrease. The answer should indeed be D, where we saying the acceleration is 0, right? So that's how you would do multiple choice questions. They require you to know your theory and also a little bit of playing around with the formulas that we have looked at, right? So I hope that makes sense. If you have any questions, please leave them on the comment section, and feel free to also email me some of the multiple choice questions that you'd like me to do. I'll do the lessons, the videos on them, and share online. See you on the next video when we do long questions.